Hi friends, in this video we are going to learn about signals. The basic and most important concept in electronics and communication is signals. Okay, by the end of this video you will know exactly what is signal and examples of signal and how to represent them. Let's see the definition of signal. A signal is any physical quantity that varies with time, space or any independent variable. For example, voltage that changes over time, temperature changes throughout the day, or even our heartbeat changing while running. Okay, so signal should be any physical quantity that is varying with respect to time, or it could be varying with respect to independent variable. Okay, let's see the real-time examples of signals. Let's take the stock market index. If we look at the Sensex or Nifty value, it does not remain same all the time. Okay, it keeps going up and down throughout the day based on buying and selling activities. This change in value over time is signal. Okay, this change in value over time is signal because it carries financial information and it varies with the independent variable. Okay, here the variable is time. The next one is temperature during the day. This is the another example. Here in the morning it may be cool. Okay, then it increases towards noon and again drops at night. If we record this temperature at different times and plot it on a graph, we get a temperature signal. The independent variable here is again time. Next one is speech signal. Okay, next one, speech signal. When we speak, our voice amplitude changes continuously like this, right? Okay, our voice amplitude changes continuously. If we record it, the waveform we get is called a speech signal. This is the speech signal. It contains information in the form of sound pressure variations over time. Okay, so next one is heart rate. Okay, our heartbeat also varies, right? When we resting, it may be 70 beats per minute, but when we run or do exercise, it increases to 120 or more. Okay, if you plot the heartbeat rate over time, that's a heart rate signal. Okay, so from this we can learn what is signal. Signal can be any physical quantity that varies with the time, space or independent variable. Okay, let's see how to represent a signal. Okay, what are the way to represent a signal? There are 4 common methods to represent a signal. First one is functional representation. What is functional representation? It is a mathematical representation or it is a equation, formula. Okay, functional representation is a mathematical equation or formula. So here x of n is the signal, that is equal to n plus 1 divided by 2. N varies from 0 to 5. If you are substituting the values for n is 0. First, if you are substituting the value is 0 means 0 plus 1 divided by 2 is equal to 1 by 2, right? Then the value is 0.5. Okay. So next, if you are substituting the value for n is 1 means 1 plus 1 divided by 2 is 2 by 2. 2 by 2 means the answer is 1. Next, we substitute 2. 2 plus 1 is 3. 3 by 2 is 1.5. Again substitute n equal to 4. 4 plus 1 divided by 2 is 5. 3. 3 plus 1 divided by 2 is 4 by 2, that is 2. Then 2.5, then 3. Okay. So this is the values for this x of n. So functional representation means that is the mathematical equation or formula. Next one, graphical representation. Here we draw the signal on a graph amplitude. Okay, so here we draw a signal on a graph. Here amplitude on the vertical axis and time on the horizontal axis. Amplitude means that is sample number. Okay, this makes it easy to see the shape and variation of the signal. So here this is our for 0 the value is 0.5, correct. Then 1 means x of n value is 1.0, that means 1. For 2 the value is 1.5. So this is the graphical representation. This is the easiest method to represent a signal. So next one is tabular representation. In this method we list the values of the signal in table for different time instance. Okay. Then last representation is sequence representation. Okay. Sequence representation means we just write the signal value. So this is the signal value. We just write the signal values in the curly bracket. Okay. Here the value is start from x of 0. So x of 0 value is 0.1. Then this value is x of 1, x of 2. Okay. This is the x of n value. This is the sequence representation. Okay. Then finally, let's see the applications of signals. First one, communication systems. Here signals are the backbone of communication. Okay, signals are the backbone of communication, whether it is a phone call, a video chat, or sending a file over the internet. The information is carried as electrical or electromagnetic signals, right? So mainly we simply say that is the signal, we use signal to communicate in between two devices for in communication systems. Okay. Next one, control system. Machines and robots use sensor signals to adjust their movement, speed or performance automatically. For that we are using in control system. Then audio processing. Okay. In this in devices like audio devices like music players, hearing aids, then audio signals are processed to improve clarity, remove noise or recognize speech. For that we are using in audio processing. Okay. Next one, biomedical engineering. Biomedical engineering means heart signal, that is ECG, then brain signals EEG, muscle signal. Okay. Signals helps doctors diagnose health problem. Okay. Then image processing. For image processing, signals in the form of pixel values are processed to enhance quality, detect, adjust or analyze medical scans like MRI and X-ray images. X-ray images. Okay. So these are the applications of signals. Okay. In many places we are using signals to represent the information. Okay. So friends, a signal is simply a way to represent information that changes over time or space. In the next video, we will learn how to classify signals into continuous, discrete, analog and digital. Thank you.